This content is produced by PassTheCSLB, an independent educational channel. I am not a licensed contractor, attorney, or engineer. This is exam preparation material only, based on publicly available CSLB study resources. Nothing here constitutes legal, professional, or engineering advice. Exam content is set by PSI and the CSLB and may change. Always verify current requirements against official CSLB materials. I cannot guarantee any exam outcome. Now let's get into it. Before I walk you into roof types and slope tables, I want to plant something in your mind. There is one specific number in California Roofing Safety Code that directly contradicts what federal training has told you. If you have sat through any occupational safety certification in the last 20 years, you have memorized the wrong answer for a California licensing exam. I will tell you exactly what that number is and why the difference exists. Keep that in the back of your mind as we go. This episode covers roofing fundamentals, roof types and identification, slope and pitch thresholds, California Fire Code material restrictions, framing components, estimating by the square, flashing sequences, and the California-specific safety and legal numbers that catch experienced contractors off guard. Official preparation resources consistently identify roofing within the core trade section of the General B exam, which accounts for 30% of the total assessment. I want to start with roof types. I know you know what a gable roof looks like. What I want to give you is the examiner's language for the structural characteristics and architectural implications that drive the questions. The gable roof is the most common residential configuration in America. Two rectangular sloping planes meet at a central ridge, leaving triangular wall sections called gables at each end. Simple to frame, economical, excellent drainage. Its structural liability is exactly those vertical gable ends. Flat surfaces with no aerodynamic profile. In a high wind event, they catch lateral pressure like a sail. That vulnerability is the reason the hip roof was developed. A hip roof eliminates gable ends entirely. All four sides slope downward to their perimeter walls. No flat vertical faces. That continuous sloping profile deflects wind load rather than catching it. Hip roofs are the standard in coastal and storm-prone zones for exactly that reason. The trade-offs are real. More complex framing, higher cost, less usable attic volume. Official preparation resources identify those trade-offs as key content. The mansard roof has two distinct slopes on all four sides. The lower slope is extremely steep, sometimes nearly vertical. The upper slope is shallow. Think of the old Second Empire buildings in San Francisco's Victorian neighborhoods. That steep lower face is not just decorative. It creates a full additional story of usable space inside the roof structure without technically adding building height. The gambrel does the same thing, but only on two sides, leaving gable ends exposed. Think barn. The Dutch hip is the intelligent compromise, dominant hip structure with a small gable section inserted near the ridge ends. Wind resistance of the hip, ventilation, and character of the gable. When two wings of a building intersect at right angles, two junction types form. At exterior corners where sloped planes face outward, a hip. At interior corners where sloped planes face inward, a valley. Valleys concentrate the drainage from two converging roof planes. They are the single most vulnerable water intrusion point in any roofing assembly. That principle is going to come back when I cover flashing. Dormers. A shed dormer has a single flat sloping plane projecting outward, the clear choice when the goal is maximum interior headroom and floor width in an attic conversion. A gable dormer has its own peaked miniature roof. The eyebrow dormer is a continuous wave-like arch without vertical sidewalls. Architecturally distinctive, requiring advanced carpentry and flexible materials because standard valley flashing cannot follow that curved geometry. Official preparation resources specifically note the eyebrow dormer as a testable identification item, which is why I'm naming it here, even though you may build it rarely. Before I get into slope, I want to tell you the story that explains an entire section of California code. Once you know why the rule exists, you will not forget it. In October of 1991, fires started in the Oakland and Berkeley Hills. Within hours, it had killed 25 people and destroyed nearly 3,000 structures. The tunnel fire became one of the most destructive urban fires in California history. When investigators analyzed the fire's spread pattern, one material kept appearing: untreated wood shake roofing. Burning embers landed on shake roofs, ignited them, and the fire jumped from structure to structure faster than wind alone could explain. The shakes were acting as stepping stones. That fire, and others before and after, drove California to create what are now very high fire hazard severity zones and to write California Building Code, Chapter 7A alongside Health and Safety Code, Section 13,132.7. The language of those sections is precise. Wood shakes and shingles are prohibited in designated very high fire hazard severity zones. Not restricted, not conditionally permitted, prohibited. And the specific provision that matters for exam preparation. The prohibition applies regardless of any fire retardant treatment the product carries, and regardless of any Class A fire resistance rating. No treatment overrides it. I point that out deliberately. If you are an experienced roofer, you know that treated wood shake products exist with Class A ratings. Official preparation resources specifically cover whether candidates know that the rating becomes irrelevant inside a designated zone. The answer is prohibited. Now slope. Before I put the chart up, I want to give you a memory anchor I call the Blackjack system. The 5 key slope numbers for this exam are 1/4, 2, 4, 8, and 21. Quarter, 2, 4, 8, Blackjack. Quarter is the flat roof minimum. 2 starts the low slope zone. 4 is the standard minimum for asphalt shingles. 8 is the walkability limit. 21 is mansard territory, Blackjack. Say that sequence once: quarter, 2, 4, 8, Blackjack. It covers the 5 most testable slope thresholds in roofing code. I have the slope chart up. Let me walk through each category. 1/4 to 12 is the California Building Code minimum slope for any roof that must drain. A perfectly level surface is not a flat roof. It is a pond waiting to happen. Standing water destroys every roofing membrane, every fastener, and the sheathing beneath. The 1/4 minimum is the angle at which gravity reliably moves water toward a drain rather than letting it sit. Between 2 to 12 and 4 to 12, I think of this as the yellow zone. Asphalt shingles can be installed here, but the California Building Code requires double underlayment. Here is why. At that shallow angle, water moves slowly, and slowly moving water is vulnerable to being pushed backward, uphill, by wind pressure, capillary action, or ice dam hydraulics. A single layer of underlayment cannot reliably resist that backflow. 2 layers can. If a question gives you a 3 to 12 slope with asphalt shingles and asks what is required, double underlayment is the answer. 4 to 12 is the standard minimum for asphalt shingles under normal installation without modification. That is the most directly testable slope number for shingle roofing. Below it, you are in modification territory. At it and above, standard protocols apply. 8 to 12 is the walkability limit. At approximately 33.7 degrees from horizontal, most workers lose reliable footing. Above this threshold, you must deploy roof brackets, specialized staging, or continuous personal fall arrest systems before anyone steps onto the surface. 21 to 12, Blackjack, is where the physics of standard shingle installation stops working. I want to give you the physical picture because it makes this permanent. Every asphalt shingle has a factory-applied adhesive strip on the back that bonds to the shingle below it, under the compressive weight of the shingle above. At normal slopes, gravity presses the shingle down, the bond activates, and the tab seals. At 21 to 12, the shingle is nearly vertical. Think of pressing tape to a surface that is almost upright. The tape slides. No compression, no bond. The sealant strip never engages. The first serious wind event lifts those tabs like cards in a deck. The code response is 2 requirements working together: 6 nails per shingle instead of the standard 4, and manual hand sealing. A contractor or laborer pressing a quarter-size dab of asphalt cement behind every single shingle tab by hand. You are substituting labor for what gravity does for free on a normal slope. Skip either requirement on a mansard roof, and you have a documented failure waiting for a storm. Materials. I want to give you a framework before the details. I organize roofing materials into 3 functional layers: steep slope surface materials, low slope membrane systems, and underlayment. Hold that structure. Steep slope surface materials first. Asphalt shingles dominate residential construction. 3-tab shingles are flat profile, economical, and lower wind rated. Architectural shingles, also called dimensional or laminated, are layered, heavier, rated for higher wind speeds, and carry longer warranties. Fastening under standard installation at 4 to 12 and above, 4 nails per shingle. In the yellow zone between 2 and 4 to 12, 4 nails plus double underlayment. Above 21 to 12, 6 nails plus hand sealing. One fastener detail worth having precisely. The nail must penetrate a minimum of 3/4 of an inch into the roof sheathing. Standard oriented strand board is 15/32 of an inch thick, which is less than 3/4 of an inch. When sheathing is thinner than 3/4 of an inch, the code requires the nail to go completely through. That is a precision distinction. Clay and concrete tile is architecturally central to California construction. Clay tile runs 600 to 1,000 pounds per roofing square. Concrete tile runs 900 to 1,200. California code requires structural engineering verification when roofing materials exceed 6 pounds per square foot. Tile almost always crosses that threshold. An engineer must review the framing before installation proceeds. Low slope membrane systems. I want to give you a 3-word memory anchor: tape, weld, weld grease. Ethylene propylene diamonomer is synthetic rubber, typically black or white, with seams bonded by contact adhesive or specialized seam tape. Not heat welded. Tape. Thermoplastic polyolefin is the white reflective membrane you see on commercial roofs across California. Seams are heat welded. The material fuses to itself using a hot air gun. Weld. Polyvinyl chloride is also heat welded at the SOMs, similar to thermoplastic polyolefin. The key distinction is chemical resistance to grease and oils, which makes it the specified product near restaurant kitchens and food service exhaust. Weld grease. Tape. Weld. Weld grease. Ethylene propylene diamonomer. Thermoplastic polyolefin. Polyvinyl chloride. Seam method and one distinguishing characteristic for each. All 3 require a minimum slope of 1/4 to 12. Modified bitumen bridges built up roofing technology and single-ply membranes. Styrene butadiene styrene provides rubber-like cold weather flexibility. Atactic polypropylene provides ultraviolet and heat resistance and is typically torch applied. Both are low slope products with the same 1/4 to 12 minimum slope. California Title 24 Energy Code requires cool roof certification for many commercial re-roofing projects. The Cool Roof Rating Council uses 2 metrics: aged solar reflectance, how efficiently the material reflects solar energy, and thermal emittance, how efficiently it radiates away absorbed heat. High scores on both reduce mechanical cooling loads, which is why thermoplastic polyolefin dominates California commercial re-roofing. Ice and water shield is required in California at elevations of 4,000 feet and above. It must extend from the lowest edge of the roof deck to a point at least 24 inches inside the interior face of the exterior wall line. Interior face, not exterior face, not the sheathing edge. Interior face, that precision matters. Roof framing components. These are terminology questions on the exam. The test is whether you know the precise mechanical function of each member, not just its name. Ridge board versus ridge beam. I want to give you an analogy that makes the difference physical and permanent. Picture 2 people leaning toward each other with their foreheads touching. Neither can stand without the other. They hold each other up through mutual pressure. That is the ridge board system. Opposing rafters lean against each other in compression, with the ridge board simply holding them in position at the top. The consequence of that compression relationship: the rafters push outward against the exterior walls. Something at the bottom must tie those walls together and resist the outward thrust: ceiling joists or rafter ties. Remove those horizontal ties for a vaulted ceiling without compensating structurally, and the walls spread, The ridge sags. A ridge board carries zero structural load. It is a positioning device. Now picture a chin-up bar bolted to the ceiling. Rafters hang from it instead of leaning against it. The bar carries the load. That is the ridge beam, structural, supported at both ends by posts. Rafters in this system are in tension, not compression. No outward wall thrust. A ridge beam is required whenever ceiling joists are eliminated for vaulted or cathedral ceilings, and also when the roof slope is below 3 to 12 because the compression geometry of opposing rafters does not function reliably at very shallow angles. Rafter ties versus collar ties. 4 words. Low ties, walls, high stops, pull. Rafter ties are in the lower 1/3 of the attic space. They tie the two exterior walls together and resist the outward thrust generated by the downward weight of the rafters. They prevent the walls from spreading apart. Ceiling joists typically serve this function simultaneously. Collar ties are in the upper 1/3 of the attic space. They prevent the rafters from being pulled apart at the ridge by wind uplift. Wind pushing upward under the eaves applies a prying force at the ridge. Collar ties hold the opposing rafters together at that joint. Different elevation, different force, different function. Low ties, walls, high stops, pull. Say it once and it is yours. Common rafters run the full span from wall plate to ridge. Jack rafters are truncated. They terminate at a hip or valley rafter instead of running the full span. Hip rafters run diagonally from exterior building corners up to the ridge. Valley rafters run from interior corners upward through the concave channels where two roof planes converge. Here is something worth holding about valley rafters. Every jack rafter on both sides of a valley dumps its load into the valley rafter. That member carries accumulated loads from both planes like a sloped floor girder. Size it wrong and the valley sags visibly over time. An experienced inspector can see a sagging valley from the ground and knows exactly what it means. Estimating. 1 roofing square equals exactly 100 square feet of actual roof surface. Everything in roofing is ordered and priced by the square. The most common and costly estimating error in roofing, calculating the flat horizontal footprint of the building and treating that as the roof area. It is not. A sloped roof covers substantially more three-dimensional surface than the flat plan beneath it. At a 12 to 12 slope, a 45-degree angle, the actual roof surface is 41.4% larger than the plan view. Order from the flat plan on a 12 to 12 slope and you run nearly half a project short. Order from it on a 6 to 12 slope and you are still short by 11.8%. To get the true roof area, multiply the flat plan area, including all overhangs, by the slope correction factor for the specific pitch. I have those values on the chart. 6 to 12, 1.118, 8 to 12, 1.20, 12 to 12, 1.414. Let me walk through a complete example so there are no gaps. Building footprint, 40 feet by 50 feet, gable roof at 6 to 12. Overhangs, 2 feet on each long side, 1 foot on each short end. Step 1, plan area with overhangs. Long side 50 plus 1 equals 52 feet. Short side 40 plus 2 equals 44 feet. Plan area 52 times. 44 equals 2,288 square feet. Step 2, apply slope factor. 2,288 times 1.118 equals 2,557 square feet. Step 3, convert to squares. 2,557 divided by 100 equals 25.57 squares. Step 4, apply waste. Simple gable gets 10%. 25.57 times 1.1 equals 28.13 squares. Round up to 29. Always round up. Step 5, bundles. 3 bundles per square for standard shingles. 29 times 3 equals 87 bundles. Not everything is estimated by the square. Field shingles and underlayment cover the roof plane, estimated by the square. Starter strips, ridge caps, drip edge, and step flashing. Trace the perimeter and peaks, estimated by the linear foot. pipe boots, and kick-out flashing, counted by unit. Waste factors: 10% for simple gable, 10 to 15 for a hip roof, 15 to 20 for complex cut-up roofs with multiple valleys and dormers. Flashing: one principle governs every flashing decision. Gravity is your only reliable waterproofing agent. Every component must position water so it lands on top of the material below. Never behind it, never under it. Sealants degrade over years. Gravity does not. Drip edge at the eave versus the rake. The sequence differs, and the reason is the direction of water at each location. At the eave, the low horizontal edge, drip edge metal goes directly to the deck first. Then underlayment laps over it. Water running down the underlayment hits the metal and sheds cleanly into the gutter. Reverse that sequence and water tucks behind the metal flange, wicks backward into the fascia board, and begins a rot process that is invisible from the outside until it is already significant. The homeowner calls. You cannot find the source from the roof surface because everything looks fine from there. It is the eave sequence that was reversed. Add the rake, the sloped gable edge, underlayment goes down first, then drip edge is installed over it. At a gable end, wind-driven rain pushes sideways across the edge. Without the drip edge clamping the underlayment down against the deck, wind gets under the exposed edge and lifts it. Water follows the wind under. Memory anchor: eave under, rake over. At the eave, the drip edge goes under the felt. At the rake, the drip edge goes over the felt. Eave under, rake over. 4 words. Adjacent sections overlap a minimum of 2 inches. Fasteners, maximum 12 inches on center. California specific: valley flashing must be installed over a minimum 36-inch wide. Underlayment running the full length of the valley. Some preparation materials reference 24 inches. That is the International Residential Code number. California is stricter. For a California exam question on valley underlayment width, the answer is 36 inches. Chimney flashing uses a 2-layer sliding system engineered specifically to accommodate differential movement between masonry and wood framing. A masonry chimney sinks with its foundation. A wood roof frame racks in seismic events and cycles thermally. Rigidly attaching a single flashing piece to both eventually tears it apart. The solution is a telescope. Picture 2 cylinders that overlap and slide independently of each other. Step flashing: individual L-shaped pieces woven into each shingle course along the chimney sides is the inner cylinder. It moves with the roof. Counter flashing is cut and embedded into the masonry mortar joints and folds down over the step flashing. It moves with the chimney. The 2 pieces maintain a watertight, overlapping connection without being fixed to each other. That independent sliding is the engineering solution. On the upslope face of the chimney, when the chimney width measured perpendicular to the slope exceeds 30 inches, a cricket, also called a saddle, is required. A cricket is a small peaked structure built against the upslope chimney face that actively diverts water and debris around the obstruction. Without it, a chimney wider than 30 inches creates a pooling zone that produces a slow-motion warranty claim. Here is the number I promised you at the start of this episode. You probably know 6 feet as the fall protection trigger for construction work. Federal occupational safety regulations say 6 feet, and that number is on every safety card, every toolbox meeting outline, and every certification course in the industry. Here's the California answer for warning line placement on low-slope commercial roofs: 5 feet from the unprotected edge. California's Title 8 Safety Code, Section 1730, specifies 5 feet. Federal says 6. California says 5. On a California licensing exam, if you write 6 feet for warning line placement, that is the wrong answer. I wanted you to feel that discrepancy. That is how it sticks. Roof jack systems. Personal safety lines are required concurrently when the slope exceeds 7 to 12. That is California's Title 8, Section 1724. Parapets. A parapet must be a minimum of 24 inches high to qualify as the sole fall protection method on a steep or monolithic roof. A fall protection plan, the formal alternative to conventional fall arrest equipment, is only permissible when an employer can demonstrate that conventional fall protection is infeasible, not expensive, not inconvenient, infeasible. That word carries legal weight. Heat illness prevention is California-specific and aggressively enforced. California's Title 8, Section 33, 95. At 80 degrees Fahrenheit, shade must be present and accessible to all outdoor workers. Not scheduled, not available by request, present. At 95 degrees Fahrenheit, high heat procedures activate. Mandatory communication check-ins, buddy systems, and pre-shift review of heat illness symptoms. Any worker who feels they are overheating may take a preventive cool-down rest of at least 5 minutes in the shade without waiting for a break schedule and without supervisor approval. Contractor Law. Here's the mnemonic I want you to walk away with. 500 triggers the paper, 1,000 caps the down, 20 days to notice, 90, 60, 30 on the lien, 3 to cancel, 5 if 65. 500 triggers the paper. Any home improvement contract exceeding $500 in combined labor and materials requires a written contract under Business and Professions Code, Section 7159. The contract must contain a mechanic's lien warning in 12-point boldface type. 1,000 caps the down. The maximum legal down payment is the lesser of 10% of the contract price, or $1,000. On a $20,000 contract, 10% is $2,000, but $1,000 is the lesser number, so $1,000 is the legal cap. On a $6,000 contract, 10% is $600. $600 is the lesser number, so $600 is the cap. Always find the lesser of the two calculated values. Collecting more than the legal maximum is a potential misdemeanor under California law, and the licensing board can use it to suspend your license. Not for bad work, for the wrong deposit amount. 20 days to notice. Subcontractors and material suppliers must serve a preliminary notice within 20 days of first furnishing labor or materials. Miss the window and lien rights are restricted to only the work performed in the previous 20 days. 90, 60, 30 on the lien. The prime contractor has 90 days to record a mechanic's lien after project completion, with no notice of completion filed. If the owner files a valid notice of completion, the prime contractor's window shrinks to 60 days and the subcontractor's window shrinks to 30 days. 3 to cancel, 5 if 65. Standard homeowners have a 3-day right to cancel a home improvement contract signed at their residence. Homeowners who are 65 or older have 5 days. That demographic-specific extension is a testable distinction. Now the workers' compensation trap, and I want to tell you this as a story because the distinction is important. A General B sole proprietor with no employees can file a workers' compensation exemption with the licensing board. That is a legitimate option for that license classification. Here is what an experienced roofer getting their own license might not know. A C-39 roofing contractor cannot file that exemption. Not as a sole proprietor, not with 0 employees, not ever. Business and Professions Code, Section 7125 classifies C-39 as a high-risk trade for which the exemption is not available. Picture a roofer with 15 years of experience who finally gets their C-39, sees the sole proprietor exemption path available to a General B in the same business situation, files it, thinking it applies to them, and months later finds their license in jeopardy over an administrative error they did not know they were making. The exemption available to a General B does not exist for a C-39. Know that before you ever touch an exemption form. One more, a General B contractor can legally self-perform rooftop solar panel installation without a C-39 or any solar specialty license. California recognizes solar installation as inherently involving 2 or more unrelated building trades, structural and roofing work combined with electrical work, which places it within the General B scope of self-performance. Compact recap, slope, quarter, 2, 4, 8, Blackjack. Materials, wood shakes prohibited in very high zones regardless of treatment. 6 pounds per square foot, triggers engineering review. Oriented strand board nail penetration through if thinner than 3/4 of an inch. Membrane seams by type. Tape, weld grease. Framing, ridge board positions, ridge beam supports. Low ties, walls, high stops, pull. Estimating, 100 square feet per square, Multiply plan area by slope correction factor. 10% waste for gable, 15 for complex, 3 bundles per square. Flashing, eave under rake over, valley 36 inches in California. Cricket at 30 inches, counter flashing slides like a telescope over step flashing. Safety, 5 feet for warning lines in California, not 6. Shade at 80 degrees, high heat procedures at 95. Law, 500 triggers the written contract, 1,000 or 10% down payment cap, lesser of the two. 20 days for preliminary notice, 90-60-30 on the lien. 3 to cancel, 5 if 65. And C39 cannot claim the workers' compensation exemption. Ever. I know what studying for this exam actually looks like. You are not at a desk with a highlighter. You are living your life and trying to fit this in between jobs, between calls, in a parking lot with 15 minutes to spare. I built the practice quiz for this episode around that reality. It is audio-based. 12 questions, read aloud. You answer by tapping. No reading required. Go to the description below this video. You will see a link that says PassTheCSLB. Tap it. It will take you straight there. If anything I covered did not land, a number that still feels slippery, a rule you want me to go deeper on, put it in the comments below. I read every single one and I answer them. This is a conversation, not a broadcast. Subscribe if you are working toward this license. I am building this series episode by episode through every section of the General B exam. Every testable number, every California-specific deviation from the national standard, every concept that shows up in official preparation materials. You stay subscribed, you stay on track through every topic until you pass. Now go get it.